Let's start. Good afternoon. Welcome to everyone to this new event of the EMS webinar series. Let me start by noting that this webinar is being recorded and it will be later published on the EMS YouTube channel. Please send us your suggestions of new topics or a speaker to us. Whatever topic you consider could be interesting or attractive to our audience would sure fit in this format. And now a few words about formalities. First, we'll have a presentation delivered by our invited person, roughly half an hour, 30 minutes, and then we'll invite questions from the audience, either via the chat function that will only be seen by the panelists. Use please the chat to write your questions, or alternative by raising hands, clicking on the corresponding icon on your screen. In this case, turn your micro on and your camera also if you wish. And now let's turn to our speaker today. Our speaker is Professor Ricardo García-Herrera. He's a professor of atmospheric physics at the Complutense University of Madrid. He's a specialist in climatology, and among his research interests, we may include topics as analysis of synoptic patterns or weather and climate events. In the last 20 years, he has worked with different documentary sources with a special emphasis on marine logbooks. He is author or co-author of more than 200 papers in scientific journals, and he has coordinated many international and national research projects and has supervised around 15 PhD theses. He is also not worthy to mention that he has been president of IMET, of the Spanish Meteorological Service. This is a good reason for explaining his good knowledge of the research and operational meteorology, both branches. Today, Ricardo will present a very appealing topic, combining both climate and history. And the title appearing in your screen is Seamen Records of Past Climate. I'm sure you would enjoy very much this talk. Please, Ricardo, thanks for agreeing to deliver this talk, and please go ahead with your presentation.
Thank you, Ernesto. First of all, thanking you and the EMS people for this invitation. And I would like to express my acknowledgement to my colleagues, mostly David Barrio Pedro, David Gallego, and the late Dennis Wheeler, because we together started this trajectory of research that you are going to see abstracted in a few slides. The first thing is, okay, the question when Ernesto asked me to make a presentation, I said, okay, this is the talk that I want to give. And it was a difficult decision because I could have told you about the irrigation ceremony and droughts in the Mediterranean, or about how the taxes of the church in the Canary Islands help us to understand precipitation variability, or even more challenging, how the longest lasting commercial shipping line in history, which was the Manila Galleon, helped us to identify variability in the monsoon draft. But anyway, after talking to Ernesto, I will focus on this issue of the logbooks, which we have been working on in the last, as Ernesto said, 20 years or so. So I will see, you will see which was the language they use, how this can be transferred into modern terms information, and then the application we have to use for this. Okay, the first thing is that that you have taken into account when you look at documentary sources is that the work was very similar, but the documents didn't see that similar as they are today. What you are looking here is it is a birthday present from the Jesuits to King Ferdinand VI of Spain. And this is a map of the Pacific Ocean. Here you can recognize the California Peninsula. Here the Philippine Islands, and this is the China coast. But as you can see, you can recognize several items, but this is something more difficult to identify, which it says the sea or bay of the west, which of course, which is pretty close to the New Mexico border. Of course, this doesn't match with our present day knowledge. And this is an issue that you have to take into account when you work with this type of documents. Okay, but the documents that we are going to talk about today are those which were issues from this. Okay, this is the flagship of the Spanish fleet in the Trafalgar battle, the Santísima Trinidad, which was defeated by the British fleet commanded by Admiral Nelson. I will ask you to make an exercise to see what kind of people you associate to this type of ships, okay? And this will help you to see how old are you, because you can associate this to Errol Flynn playing the Captain Blood in this series of films, but perhaps if you are a little bit younger, you will associate this ship to another movie, which would be The Immunity of the Bounty, the first version with Charles Lawton and Clark Gable. If you are a little bit younger, you will associate to the same movie, but the second version with Marlon Brando. But if you are even younger than that, you will think of Master and Commander with Russell Crowe. And if you are just a very, very, very young person, you will associate this to this series of Pirates of the Caribbean. But the reality wasn't like what you can see in any of those pictures. The reality was more with guys as these two, which are Jorge Juan and Antonio de Ulloa, and they were excellent mariners, but also excellent scientists, because you have to take into account that these ships were the fastest engine on Earth at that time and highly sophisticated. So there was not a lot of fun sailing on these ships. In fact, there's a beautiful view of this by Virgilio Piñeira, who is a Cuban poet, and says the damn circumstance of water everywhere. So most of the days on board were a strict routine under a military order, because well, you know, sometimes you have to order that people coming up the mast under a very hard weather, and like 50 people had to do it without just questioning it. So it's a lot of scientific knowledge, a lot of discipline. And for us, the most important thing is that there were like observing platforms, because for them, their ability to observe weather and sea was the main priority, because if they didn't interpret properly how weather and sea were changing, it wasn't the problem that they should arrive later. The problem was that they could die, because they could enter into the doldrums, and then just they could be stirred there for weeks and they could die of starvation, or they could meet a storm and then the ship could be destroyed. Okay, but so once we know that we have this type of platforms, what kind of information can we get? The first thing is that they had a lot of tools to know how they were sailing and in which direction and in which speed. They had the sextant, the needle, the hourglass, and the log line. If you are not familiar with this, basically what they did was they throw this from the back of the ship and they counting for a certain period of time with the hourglass. They saw the longitude of the rope which has been just extended, and in this way they were able to compute the speed that they were traveling. So if you can see, to help them to get a fasted computation, they put knots every certain distance, and that's why even today the speed on the sea is recorded in knots, nautical mile per hour. Okay, fortunately for us, those guys, well, they write everything. What you have here is an example of a logbook. It's a Spanish ship. It corresponds to Friday the 5th to Saturday the 6th, August 1796, a ship sailing from La Coruña, northwestern Spain, to the Caribbean. And then you can see that there's quite a lot of detail, and there's annotations which taken hourly. And you can see that here is what I have marked is the wind direction: east, west, northwest. And every time they had a change, this was recorded. And in this other column, it was the strength. Okay, so the question that we asked at the beginning was, okay, can these observations of wind be used to extend our knowledge back in time about the weather of or better than the weather, the climate over the oceans? Because as Ernesto has said, I have been working with historical documents, but I'm not interested in the history of climate. What I am interested is in getting the longer period possible to better understand climate variability. So what our interest was, can we match these records with present day records? With this is not a new idea, by the way, the use of these logbooks to make such exercise. What you can see here is the first representation of the trade winds. You can see here in the northern hemisphere, in the southern hemisphere, and the author was a very well-known person. It was Halley, the astronomer, and he drew this map from information taken from the logbooks. So having all these antecedents, the question is the information that they recorded how objective was? Because you have not seen numbers in the logbook. What you can see is things like calm, light air, light breeze, very fresh, hard. Was this something that every captain or pilot used up there according to their experience, or was there something more objective behind this? Well, to make the story short, what we found was that these are written expressions, but they were not as subjective as you could think at the first sight, because you can see that, for instance, in this case, where this is an example, thank you for a book from Alexander Dalrymple, when you can see is that this term, for instance, gentle breeze, is associated to a description which is which has a correspondent with the speed of the ship. What we saw is that before the Beaufort scale, which is currently the wind scale for used in marine terms, there were a lot of well, not a lot, but there were several scales which were used by these people, but were quite similar. And the interesting thing is that there were not only from a certain language or country, because you can see here the French terms associated to this scale, for instance, but also they were translated into Spanish. Why? Because or even Dutch, because when there were peace among these the main sailing powers of the time, they met in ports, and then those people, well, interchange opinion and experiences. So it was much more homogeneous than what one could expect. So we made an effort to see, okay, is there an equivalence between modern day? And then what we were able to build was this through the Claywork multilingual meteorological dictionary. What we made was build an equivalence between Spanish, English, Dutch, French dictionary of these old terms and their modern equivalents. So I think this is the most important achievement of the project, because it allows us to build series just using these terms from the mid-18th century to present. Of course, we have some problems, because if you plot the original records, then you can see something like what you see here. See, this is a ship sailing from England to the Gulf of Guinea. And you can see, as I told you, that those ships were very fast, but they were not amphibious. The problem here is that they have, until the late 19th century, they have problems in recording latitude. I like this sentence which is a very nice book called Longitude by Donna Sobel, which says, zero latitude is fixed by natural laws, while zero longitude changes according to the sands of time. What these people did was they changed it several times along these long routes of the reference meridian. And then, well, this makes that you have to check carefully the information that they provide about their location. You can see here that going to the Guinea Gulf, they went to several ports, and then they changed. This correspond to changes in the reference meridian. But on the return trip, as they didn't reach any port, there were no changes. We found through this project, well, this is the corrected version of the trip, adjusting, okay, once we knew which were the ports that they had been in, well, we had, and the distance that they had traveled on a certain day, we could adjust all these trajectories. And once you have this, well, we found that 200 meridian of reference, which this gives you an idea of the amount of work that needs to be done to adjust these trajectories to something realistic. The other question is, okay, once we know that we can fix the position, is the speed that they recorded, even when the terms we have seen that are equivalent, but did they depend on the type of ship? If it was a war ship, or it was a merchant ship, or was it a big ship or a smaller one? Fortunately, we could record, we could get records from ships sailing in convoy. For instance, these are two British ships, the Ceres and English, going to Indonesia. And these are others just sailing in South Africa. And we could compare the records of the wind force and direction. And to make things brief, well, what we could see is that they were highly correlated, and then we could use the wind spin independently of the type of seed that recorded this. With this, what you can get is something like this. Okay, this is 1 year of observations. This project has been used by people working on things like visualization. And when you can see is every color is a certain nationality. And then you can see the ships that were sailing in the different months. If you take a look at here, for instance, you can see the monsoon cycle. Here now ships are not that you don't see ships sailing. Then you can see how with the monsoon ships are sailing to India, and then after October or so they are sailing back, for instance. So you can trace here the Indian monsoon. You can trace here the Atlantic high, and there are more other types of synoptic structures that you can identify. To give you an idea, we were able to put like the 300,000 observations over the open oceans. This is the complete database, and this comes from the Dutch. This comes from the Spanish, and and so with this we were really on the point of going to where we were just more interested in, that it was what kind of applications you can do. And I will just show them a couple of examples. For instance, this, if you remember 2005, Hurricane Katrina, Hurricane Category 3, and some people claim that it wasn't unexpected and it didn't happen. It didn't happen before. What you can see, this is a paper that we made in collaboration with several colleagues from different countries. You can see the reconstruction of this hurricane, which started as a storm here, and then as it entered the Caribbean, it became stronger, and even going to a major hurricane category, just very close to New Orleans. This has been done, collecting information for different ships and different, you can see some of them, and also different records from newspapers and archives from different countries. So this gives you quite accurate information about the trajectory of the hurricane, and tells you that okay, some kind of streams are not unexpected as some people could expect or could claim. The other example that I'm going to show you is what we have built is what we call directional indices. This means that we are worried about the changes, systematic changes in the direction of the winds. The first example that we made was in this area, in the English Channel, because, well, this is a key area from the climatological viewpoint, because, well, it's in certain conditions is the entrance of storms into Europe. And the other thing is that apart from the climatological interest, it was very frequented route from the ship by the ship sailing from the Netherlands, from the UK, and from France. So this implied that we had enough density of observations to build a continuous series. So what we could build at the beginning was what we call the westerly index, and it's an index of the frequency of the westerly wind in this area. And you can see we could build this series starting 1685 to present. And then this series, for instance, tell you periods of multi-decadal variability, which is our main focus, how we can characterize decadal and multi-decadal variability that with the short instrumental record is highly difficult to capture. We have, this is, by the way, this is the longest observational series that you can find from this area of the world after the central England temperature. Okay, you can extend this, and you can, sorry, before that you can see the relationship that this series has, or this index has, with the climate in Europe. For instance, this corresponds of the signal in temperature with during summer, and this during for precipitation, and this is the signal in sorry, this is winter and this is summer. So you can see that when there's a high index, well, temperatures in winter are higher in most of Europe, and there's more precipitation in this part, and there's lower precipitation in the south. And of course, as usual, the signal is lower in summer. We extended this, and because we said, okay, we don't only have to worry about the winds, the frequency of the winds coming from the west, but we computed it's coming from the south, the east, and the north, and this allowed us to focus on the earlier part of the record, which has been called the late Maunder minimum, and we could see how this information can be just examined jointly with the North Atlantic oscillation indices, and explains you quite a lot of the variability. The last example is that we have used this kind of approach, and it means computing the frequency of winds coming from certain direction to study monsoons. We have analyzed the West African monsoon, we have analyzed the Indian monsoon, the Western North Pacific, and the Australian monsoons. And for instance, to make things brief and allow time for questions, you can see that this area, if you focus here, which is when the monsoon blows from the sea to the coast, and is affecting mostly the Sahel. As you know, the Sahel is currently one of the driest areas in the world and is experiencing a very persistent drought. This is what you can see in this record, but interestingly, since we extended this record of the monsoon until the first decades of the 19th century, you can see that this drought is something that has no precedent, but not even this, that by the end of the 19th century, the Sahel was much wetter than it is currently now. Or you can see, for instance, this trend in the Australian monsoon. So this is the type of things that we are interested in and that we have been exploiting with this type of data. And our last interest is the characterization of upwelling. Upwelling in the oceans is highly relevant because the water, well, this is a process when the cold deep waters of the sea come to the surface, and these waters are very rich in nutrients, so it implies that there are very rich fisheries areas. But the interesting issue is that they are concentrated in a very small percentage of the world surface, because around I think that in less than 20% of the areas of the globe is where most of the fisheries are concentrated. So what we have done, we have seen is that coupled with this upwelling, there are changes in the wind, and in the case of the Western African coast, when there's the upwelling, wind veers and then wind blows from the northeast. And so we have done this type of series again, and we have seen this kind of variability for the upwelling in this area of the Canary Islands. This is very relevant because so far the upwelling is characterized using satellites or buoys, and we don't have still a long-term view of the behavior of the upwelling. And so with this, I hope that I have attracted your attention, and you have some questions for me. Thank you very much.
Thank you, Ricardo, for this fascinating travel describing both the recovery of meteorological records from ships crossing the oceans and also their use for some application. Now it's time for questions, and I will ask our audience either to write their questions in the chat or raise the icon with the raised hand. Meanwhile, okay, I will start with one question for the moment. We are aware that during the last decades, a big effort has been carried out to recover data, climate data from many different sources of documents. Do you have some idea of sources, perhaps coming from not accessible archives, which are still unexplored or largely unexplored? Certain countries, certain types of sources. Do you have some idea of that? Can you comment on that?
Yeah, what we have an idea more or less is about the early instrumental observations. In fact, there's a paper published in BAMS where a group led by Stefan Broniman in Bern University, where we, after a workshop, there was a collection of all the known records of early instrumental observations that had been identified and had not been extracted yet. So, and this is really, I don't have the number now, but it's a huge amount. And in some cases, it is even underrepresented. For the rest type of records, the question I think that cannot be answered because, regarding logbooks, we still have thousands of logbooks which have not been digitized in the British archives, because the collection is so big that it has not been extracted. What we do is, when we have money, we have a certain idea, we try to go there and then to extract those logbooks on purpose. For the rest, it's very difficult to answer, as I told you, because in many cases, the archives are not organized as we expect from the climate viewpoint. I give you an example of an archive where I have been working quite often, the archive of Indies, el Archivo de Indias in Seville. You have there 8 kilometers of bundles with information from with the documents that were originated during the time that Spain had the former colonies in South America. This archive is organized not geographically, but administratively. The analyzing hurricanes. We had a couple of projects there, and the question was much more difficult because we had to go to different sections and then to identify the documents which could inform us on hurricanes. So I would say that the information about early instrumental records is more or less identified, but the information of this other type of records, well, I would say that we don't know. And as you said, there has been a lot of investment in data recovery and in the analysis of historical documents, but now I have the perception that this is not so anymore. The emphasis is put on modeling, but one record that you get, this one observation that you get, this will keep forever. But the modeling exercise are something which just will be superseded after a certain period of time. But I don't see the same interest from funding agencies to promote these data recovery exercises.
Okay, thank you, Ricardo. Vesna, do you have any question from the audience?
No, not at the moment.
Okay.
But Jose Antonio Lopez raised his hands, so
I feel it was some error at the beginning.
Yeah, but just a few seconds ago, he raised his hands again.
Okay, Jose Antonio.
So, Antonio, would you like to say something?
Yes, thank you. Yeah. Well, yeah, just a question for Ricardo. Well, first of all, thank you very much, Ricardo. It was really interesting, although I have heard you before talking about this interesting topic with also many applications. And of course, as you have just mentioned, this recovery of ancient observations is, I think, something, of course, of much value. And well, I have just curiosity about the El Niño.
Mm-hmm.
I suppose you talked about the Galeón de Manila, no? The Pacific trade route. Can you tell us something about you have discovered changes in the El Niño pattern or something? Thank you.
Yeah. Well, we tried to look for logbooks once we after this project. It was one of our our main interest. But as you can see here, let's see, that's the Spanish. Okay, the Pacific is almost empty because until the end of let's say the 18th century, the Spanish kept the Pacific close to most of the countries, and the only ship sailing is what you can see here. These are one of the few records that we could get of some Manila galleon. So as I told at the beginning, it is a completely different story because we didn't find enough logbooks. Sorry to see the. That could help us. What we wanted was to see if there was some ship sailing through the trades, and because as you know, the trades force is related to El Niño. But instead, what we did was we went here to northern Peru, to the area of Trujillo, and we collected the information of the actas capitulares, which were the records of the local government in this area. And then we were able to build a chronology of El Niño starting in the mid 16th century until the beginning of the 20th century. But it is a completely different story because it required another type of methodological approach. The interesting thing for me is that depending on the nature of the documentary source that you are using, then you will need to use a different type of methodology. What we could get from here is chronology, is a published paper. I can send it to you if you are interested in the details, or we can have another talk about this because it deserves a talk because it is really fascinating. Is that there you get a signal of El Niño, but you don't get signals of La Niña, because in this area of the world, precipitation is associated of El Niño, and La Niña doesn't have a signal. But anyway, we could get a first-hand and from primary sources information of El Niño events.
Okay, thank you.
Thank you to you, José Antonio.
Ernesto, you wanted to say something?
Yes, another question from my side. You have mentioned the difficulties linked to subjectivity of the measurements, and in some cases the need of correction, and also in some cases you need to interpret this type of data. My question is if you can use this type of data by themselves only, or you should always use this data in conjunction with other data sources?
Well, of course you need some kind of interpretation, but the type of processing that you have to make is much less than, for instance, that you have to do with when you use dendrochronology or whatever, because you don't need to use this kind of regressions just to try to transfer the width or the of a certain tree ring into a climatic signal. If I go to this example here, what I need is a compilation of different sources. All of them are documentary sources to trace back the storm. And you don't need additional judgment, but just to properly locate where the ship was and how this the wind was behaving and what was the evolution. So for this stream, you don't need any other source, and the interpretation is minimum. Okay, so I would say for the description of events, this is the best source, because it gives you, for instance, it says you that the wind started to flow from the east, and then 2 hours after midday, then started to veer again and intensified. This is a direct evidence, and it gives you a dating which is just up to the hour in this case. So I would say that for extreme events, these are one of the best sources, and you can use this without any other type of source. For the characterization of the low frequency variability is another issue, because you have to check for homogeneity and all these issues, but not more than any other sources that you use to investigate the past.
Okay, thank you.
Jose Antonio Lopez raised his hands again.
Yes, thank you, Tesla. Yeah, another question. I was wondering, Ricardo, on the influence of the fact that I suppose mariners, and for good reason, try to avoid storms, force and hurricanes, especially, and so on. What I mean, that would mean that the data are, in a sense, maybe, I don't know, biased in the sense that all the routes or the log books refer more to good weather situations than to bad weather, or is that not the case? Maybe it's on the contrary.
It's it's much more complicated. For instance, we saw that if there were changes, of course, they were very much aware of for instance, of the hurricane season or the typhoon season in the, talking of the Manila Galleon. And they were just very much aware of this, and they tried to sail to avoid this season. But also they tried to avoid the high pressure systems, because it was it could be as problematic for them. I wouldn't say that it is a bias. What I would say is that what you get is something that we can see here. You can see is what you see is perfectly where the location of the Azores High. So you cannot expect that they would cover everything. You can see here the westerlies, and so if you analyze this route, you can see the interannual variability that of, for instance, wind force here. And you can see that depending on how the anticyclone was, well, this area has also an annual variability. If you go here, then you can see clearly the monsoon cycle. So it's not that really a bias towards good weather, but just a signal of how they took into account the different weather patterns.
Yeah. Thank you, Ricardo.
Ernesto?
Yes, another from my side. You have mentioned that most, if not all, data from Spanish ships are collected in the archive of Indies. Is this the case in other countries? How much dispersed or scattered are these data? Are largely kept by one single institution by country, or are simply dispersed by among many different institutions?
In Spain, the two main collections are in Seville, in the archives of Indies, and in the archive of the Naval Museum in Madrid. In France, they are collecting CAGAN, which is the acronym for, I don't remember what archive. In the UK, the logbooks are collected in two archives, one of them in Greenwich, and the other one is, I don't remember now exactly where. And we don't, in the Netherlands, there was only a single archive. We explore other sources in other countries, for instance, the Portuguese records, which could have been very, very interesting, but apparently they were just destroyed in a fire. And these are really what we were interested were this in the open seas, and this period, these were really the main nations that were sailing during that time.
Okay, thank you.
But going to the archive is really an issue, because the first time that you go to an archive, at least the first time that I went there, it was like blind. I mean, I didn't know how to work on this. So what we have done is working always with a historian partner to work in the archives. And it's not easy, because these issues of trying to work with people who have a different background and using different methodologies, well, it's really an issue. It took us like a year to ask the historians the questions in a way that they could understand us, and that they could reply us in a way that we could understand them. So these issues of multidisciplinarity, which now the funding agencies promote so much, is not trivial, because even the same words mean different things if you are a historian or a climatologist or a meteorologist or even a geographer.
Thank you.
We have one question now in the chat from Adrian. he said there aren't records on the winds in the Mediterranean Sea. To know,
Yeah.
for example, if a medicane have occurs in the past.
When in the Mediterranean we have a problem because and the problem is the location of the position. In fact, through a project of the Clybar project, we got funding, and we had a person just extracted information from the logbooks in the Mediterranean. But the problem in the Mediterranean is that since they were very close to the coast, the reference to the location was always referred to a certain point in a given coast, and we have not been able to find a method to properly put every record on a certain point of the Mediterranean. That's why the Mediterranean logbooks have not been explored so far. And so, unfortunately, well, we have not been able to record things as like he mentioned about the medicanes. But this is something that we have not given up. We expect to have some time in a certain moment to have time to see how we can extract some coherent information from the Mediterranean.
Okay, thank you. I don't know, Vesna, if there is any other question.
No, I would just, I want to say something, well, ask Ricardo, as far as you know, does any country still collect data from ships?
Yeah, in fact, there is a lot of ships which are currently contributing to the main database of meteorological observations over the oceans, which is ICOATS, Integrated Ocean and Atmospheric Database. And this is what we get information from this part. All this part of the record is get from this, and you have millions of records from this. There's a system of what they are called the voluntary observing system, and this is promoted by WMO. Unfortunately for us, the interesting thing is that you can stem back this information, which usually starts with enough density after the World War II. We were able to extend it back by almost 100 years using these old records.
Okay, thank you.
Okay, if there is no more question, let me to finalize to thank Ricardo for this appealing talk and everyone for attending to this event. And I invite to our audience once again to submit ideas for further topics, speakers. You can send it via email or using this chat or email to the EMS Secretariat. Okay, thank you, and I expect to announce the next event within a few weeks. Please kept connected to the web page or to the information from different societies, social networks, and so on. Thank you again, and see you next time. Goodbye.
Bye.
Goodbye. Thank you.